العافية جميعا. هلا ان شاء الله راح نكمل الجزء الثالث من محاضرة الانتي كانسر ايجنتس. بلشنا بالالكيليتنج ايجنتس از جروب، حكينا اكزامبلز عليهم اللي هم النيتروجين ماسترز، حكينا عن النيتروزيورياز بالاضافة للبروكاربازين والداكاربازين. بلشنا نحكي عن الالكيليتنج ايجنتس جروب اللي هم الاورجانو بلاتينم كومبلكسز. طيب الاورجانو بلاتينم كومبلكسز these are not organic compounds only, they are complexes, which means they're organic compounds that are chelated or attached to a metal, and in that case this metal is platinum. So the platinum is the metal that's attached to those organic compounds to make those organoplatinum complexes. بالنسبة للorganoplatinum complexes, these compounds contain a platinum, and platinum is a metal that has different oxidation states, various oxidation states. شو هم oxidation states for the platinum? عندنا 4 oxidation states, 1, 2, 3 and 4. The most common oxidation state, the most two common oxidation states اللي عندنا +2 and +4. So we have 4 possible oxidation states, +1, +2, +3, +4, but the two most common ones are +2 and +4. So this metal, as you can see, has a positive charge, which means it's an electron deficient, it's an electrophilic center. It's a center that likes electrons. And so these metals are electron deficient metals that act as a magnet for electron-rich DNA nucleophiles. لما نحكي عن DNA nucleophiles, they could be the nitrogen of guanine, as we said earlier. So basically those compounds, as we can see, the platinum here in this structure is an electrophilic center that can be attacked by DNA nucleophiles. And the most common DNA nucleophiles حكينا عنهم in nitrogen number 7 on the guanines. Alright, so these compounds, like nitrogen masters, they're basically an electrophilic center. They have an electrophilic center that can be attacked by DNA nucleophile. They're bifunctional. شو يعني bifunctional? They can accept 2 DNA nucleophiles, which means they can accept 2 nitrogens from 2 different guanines. بس الاشي اللي بيختلف عن what we have seen earlier in nitrogen masters and nitrosourea, those 2 nucleophiles or those 2 guanine moieties that are going to attack platinum, they're going to be on the same DNA strand, على نفس DNA strand, مش على 2 different DNA strands. So in that case, 2 guanines, they're usually adjacent guanines next to each other, will attack platinum to make an intrastrand alkylation or intrastrand cross-linking. واضح؟ هذا اختلاف مهم كثير بين organoplatinum complexes and the previous groups of alkylating agents اللي حكينا عنهم. لما كنا نحكي عن nitrogen masters between 2 DNA strands, guanines على 2 DNA strands بيرتبطوا على nitrogen masters. So you basically doing a cross-linking between 2 DNA strands. The 2 DNA strands. هون بحالة الorganoplatinum complexes, platinum will do an intrastrand cross-linking or intrastrand alkylation. So the platinum is basically going to do an alkylation for the 2 guanines that are next to each other on the same DNA strand. Okay? So this is an important difference between organoplatinum complexes and the other type of alkylating agents that we've seen, like nitrosourea or nitrogen masters. طبعا انا ممكن اسالك سؤال وبدي اياك تفكر فيه انت ليتقن لحالك وتجاوبه، انه ليش البلاتينم will do an intrastrand cross-linking بينما others we have seen they do an interstrand cross-linking or cross-linking between 2 DNA strands. It has to do with the size of the metal. بينما هناك كنا نشوف a longer or larger compound. I answered the question more or less, بس انت think of it and let me know if you don't have the answer. Alright, so the second thing we want to know about cisplatin. Cisplatin is one of the main examples or the oldest examples على هدول organoplatinum complexes. Here's the structure of cisplatin. It's a platinum metal, has 2 chlorines عليه موجود وعندنا 2 ammonia. So you have 2 chlorines and then you have 2 ammonias. Okay. طيب هلا لو سألتك، أنا حكيت سابقا إنه البلاتينم has 4 oxidation states. So the question here is, what is the oxidation state of platinum in cisplatin? And to know the answer of that, you need to look at the structure of platinum and see the ligands are attached or the atoms that are attached. Platinum is the metal. You have two chlorines, and if you want to look at the chlorines, they both, each of them should have a negative charge, or the chloride atom. Okay, and then you have two ammonia. The ammonia is basically a neutral atom. Okay, it's a neutral atom. So to know the full charge of this cisplatin is 0 over here, as you can see. So if I asked you what is the platinum oxidation state, you have to look what the ligands or the atoms are attached to the platinum. As you can see, you have two atoms here that have negative charge, so they have the total of those two atoms is -2. The full complex is 0, as we can see in cisplatin. So to make this 0, you have to add +2. So the platinum here is +2. The oxidation of that platinum is +2, because +2 لو جمعناهم -2, the total net charge of that complex is 0, as I've said earlier. Okay, so that complex is 0. So the ammonia here does not add any charge or contribute to any charge of that complex. It's just a ligand, a coordinating ligand sits with the platinum. بينما chlorides, the two chlorides here, they donate their electrons to the platinum. Okay, so in that complex, اللي هو cisplatin, you can think of the two chlorides over here in the cisplatin as basically they're doing a covalent bond with the platinum. بينما عندنا two ammonia groups here, they're doing coordinate bonds, and they're not really donating their electrons. Their electrons are just sitting with the platinum in one of their empty orbitals, but they're not donating it. بينما two chlorides, they are donating their electrons. They have negative charge, which means they have lone pair. They donate the lone pair. So the two chlorides are covalently attached to platinum. بينما two ammonias are two coordinating atoms. They're chelating atoms or coordinating atoms to platinum. And so you should know, هلا لازم تعرف كيف لو سألتك شو الاكسيديشن ستيت of platinum in cisplatin. ليش انها +2؟ لانه في عندنا two chlorides. The two chlorides have two negative charges. Platinum then should have a +2. واضحة؟ Then you should know basically in cisplatin the platinum oxidation state is +2, and the marketed organoplatinum anti-cancer agents اللي راح نحكي عنهم they're platinum 2, except one. It's not yet FDA approved, but it's platinum 4. راح نحكي عنه a little bit later. So أول خاصية بالسيسبلاتين لازم تعرفها إنه البلاتينم oxidation state is +2. أوكي؟ طيب الشغلة الثانية اللي لازم تعرفها، بما إنه +2 it's an electron deficient atom, so it's an electrophilic center that can be attacked by guanines, nitrogen, and do the alkylation. الشغلة الثالثة اللي لازم تعرفها as well إنه from the name of the if you look at the compound here cisplatin, the platinum has 4 atoms or 4 groups attached to it. 2 chlorides, 2 ammonias, as we can see here. طيب لما كنا نطلع عن الكربون can make up to 4 bonds. What is the geometry of carbon when it's attached to 4 atoms لما تكون sp3 hybridized? It's tetrahedral. So the platinum here is attached to 4 atoms. However, the geometry of that complex is square planar. خليني امسح هون الاشياء quickly عشان تكون اوضح الصورة. ما في داعي امسح، مش مشكلة. طيب اوكي. And so the basically as I said انه cisplatin has 4 different atoms attached to it. However, the geometry of that cisplatin is square planar and it's not tetrahedral. Tetrahedral, as you can think of it, زي كأنه it's a 3D structure. بينما هون cisplatin is a square planar. It's almost similar, very similar to a piece of paper. كأنك تطلع على ورقة and the ورق this paper أو هاي الورقة اللي موجودة هي فعليا planar structure. So that's how platinum is. On that piece of paper you have 2 atoms. The chlorine or the chloride atoms are in the front, and you have 2 atoms, the ammonia atoms are in the back. And this is also a fourth important feature for cis platinum, that the two chlorines or the two chlorides have to be on the same side, بينما two ammonia also have to be the same side. And basically we call this as a cis geometry. That's why it's called cisplatin, لأنه عندنا two chlorides. These two chlorides over here, they are on the same side. خلينا نحط laser pointer just to make it easier. So you have the two chlorides are on the same side and the two ammonia are on the same side. And as I said, the full geometry of that compound is just a planar structure, يعني كأنه 2D مسطح مش tetrahedral زي الكاو. Okay? So the features عشان نلخصهم of cisplatin المهمين اللي هم عندنا the first feature platinum oxidation state is +2. The second feature اللي موجودة عندنا إنه الatoms, the 4 atoms are attached in a square planar geometry مش زي الكربون لما تكون tetrahedral structure. And this is important يكون square planar geometry لأنه the compound has to sit between the two DNA strands, so it has to be a flat-like shape, very flat. إذا كان large structure, it might not fit easily between the two DNA strands and get closer to one of those two DNA strands to alkylate it. And the third feature اللي هم the two atoms, the two chloride atoms has to be in the same side, two ammonia has to be in the same side, so this is a cis geometry. So again, 3 features: platinum +2. You have cis geometry and you have square planar geometry. These are very important features to have an active compound. طيب خلينا نشوف كيف cisplatin works specifically. Cisplatin is administered by IV route, and so it's given to the patient by IV administration. Once you administer that cisplatin to the patient in the blood, cisplatin will stay in its form, this form اللي هو عليه 2 chlorides, 2 ammonias, and that's because the bloodstream has a high chloride concentration. So those 2 chlorides will stay with the cisplatin in the bloodstream. They're not going to be displaced by water, as we will see later. لأنه في عندنا high chloride concentration موجود في the bloodstream. Once it goes inside the cell, either by passive diffusion or carrier-mediated transport, one of those 2 pathways that it could take to go inside the cancer cell, the chloride concentration inside the cancer cell is much lower compared to the chloride concentration in the blood. And so basically what happens over here, once this cisplatin goes inside the cancer cell, now it will be exposed to a process that we call aquation or hydration process. And that aquation or hydration is those 2 chlorides will be replaced by water molecules. طيب هلا قبل ما ابلش اشرح الميكانيزم مهم تعرف ان الكلورايد عليها -1 التشارج تبعتها. الووتر شو التشارج تبعتها؟ H2O 0. So if you lose a chloride and replace it with water molecule, the total complex charge will be +1 لانك كأنك خسرت -1 استبدلت -1 تبعت الكلورايد بcompound that has 0 net charge اللي هو الووتر. So the total charge of that complex will be +1. If you lose 2 chlorides, the total charge of the complex will be +2. راح نشوف هلا هذا الحكي. So cisplatin once it's inside لما يدخل جوا الكانسر سيل راح يصير drop of chloride concentration, and that means water will be able to attack those 2 chlorides and replace them over here. And this is what happens. So once it's inside the cell, the first chloride will be attacked by water molecule, as you can see, and then you have now water replaced one of your chlorides. راح تطلع الكلورايد هون. So the net charge of that cisplatin monoaqua form اللي هو عليه mono water molecule or 1 water molecule is +1 now because you lost the chloride عليها -1 استبدلناها water. The second chloride also will be attacked by a second water molecule. It will leave as a good leaving group. كلنا بنعرف chloride is a good leaving group. تيجي water will replace that chloride. Now you have this complex اللي هو cisplatin diaqua form, and this is the active form of cisplatin. So cisplatin, you can think of it as a prodrug where the 2 chlorides will be replaced by water molecules. Now the active form is the diaqua form, or the molecule that has 2 water molecules in it, or the complex that has 2 water molecules. The net charge of platinum, diaqua form of platinum, is +2 over here, as you can see, because you lost 2 chlorides. 2 chlorides عليهم كل واحدة negative charge، كان خسرت -2 ضل عندنا +2 اللي هو just the platinum oxidation state. So when the compound has +2 Now the compound حتى لما يكون عنده positive 1 بالمونو اكو or diaco form, the compound is trapped inside the cell لأنه small molecule عليه positive charge, عليه positive 2 فعليا حتى ما راح يطلع خارج السيل أو outside the cell, so it stays inside, it reaches the DNA, and in that case what happens, خليني quickly بس أمسح هون اللي كتبته عشان تكون easier. Alright, so in that case what happens is when you have the diaco form and the 2 water molecules and plus 2 platinum, you will see that the guanine nitrogens will attack the platinum. As we see here, the platinum is basically an it's an electrophilic center, when nitrogen here are nucleophilic, so they can attack the platinum and kick those water molecules out, replace those water molecules. لاحظ ان two guanines اللي they will do the attack over here, they're adjacent guanine على نفس الستراند. تمام. And again, this is important to know. This is an important difference to know between alkylating agents اللي هم زي cisplatin or organoplatinum complexes compared to the previous one we studied, the nitrogen ester. So the two guanines over here on the same DNA strands, the nitrogen of those two guanines will attack on this cisplatinum diaco form and replace those two water molecules, as you can see over here, to generate the intra-strand cross-linked DNA. So you can see this is the intra-strand cross-linked DNA. We have nitrogen here that's basically covalently bound to platinum over here, and this is an intra-strand cross-linking or alkylation of the DNA that result in the destruction or damaging of the DNA, which means the cytotoxicity of the cell. واضح؟ So the important features to know إنه cisplatin طالما موجود بالبلاد فعليا هو راح يضرب بالفلورينيتد form. Once it goes inside the cell, it will be hydrated, aquated, راح يضاف عليه water molecules, replaces those two chlorides, and after this process you have the diaco form of your cisplatin. This diaco form will be attacked by the nitrogen of the guanines, resulting in the alkylation of the DNA or the intrastrand cross-linking. Okay. All right, so this is a very important mechanism to know how the cisplatin works. And so, as we said, cisplatin طالما انه موجود بالبلاد, it will not be replaced. The chlorides اللي موجودين على cisplatin, they will not be replaced by water. However, it doesn't mean that cisplatin is very stable in blood. Cisplatin itself is a reactive compound. It can be attacked by other nucleophiles, say thiols, for example. And as you can see, these thiols حكينا عنهم سابقا موجودين بالبلد. They could be part of either amino acids زي cysteine, or they could be part of glutathione اللي حكينا سابقا موجود as well in the blood as a protection mechanism. These thiols can attack the platinum 2. Platinum 2 especially لما يكون عليه 2 chlorines or 2 chlorides. The chlorides are very good leaving groups, and if there is a strong nucleophile زي فعليا الجلوتاثيون او الثيول specifically, the cisplatin can be attacked by glutathione, and if this happens, you destroy the activity of this cisplatin. So only a small amount of your cisplatin will be able to reach the cancer cells. Only very small amount or limited amount of cisplatin will be able to reach the cancer cells because of the attack of those thiols اللي موجودين بالجلوتاثيون or the cysteine اللي موجودين. cysteine ممكن يكون just an amino acid جزء من الالبومين. فالالبومين نفسه ممكن يعمل اتاك على السيسبلاتين، والجلوتاثيون كمان ممكن يعمل اتاك على السيسبلاتين destroying the cisplatin. So only about 5 to 10% of cisplatin can reach the cancer cell, not more than that. Most of it, 88 to 95%, will be deactivated by those thiols الموجودين بالالبومين, بالجلوتاثيون, and other proteins as well. طيب هلا شو الحل إذا؟ They thought about a solution for that problem. بما إنه الكلورايد here, as you can see in cisplatin, it's a very good leaving group. As you all know, chloride is a very good leaving group. Can we reduce that, the activity of that good leaving group? يعني نقدر نضاعف ال good leaving group characteristics of that atoms. Can we replace this chloride with different atoms that are still leaving groups but not as good as chloride to reduce the activity of this cisplatin? بدناش نخلي السيسبلاتين يصيروا attack directly in the blood، نعطيه وقت يوصل للcancer cell. So this is what they did in carboplatin and oxyplatin, as you can see, these two compounds over here. they replace the two chlorides الموجودين في السيسبلاتين بكاربوكسيليت. as you can see over here these are carboxylate. الكاربوكسيليت كلنا بنعرف كيف structure of carboxylate is negatively charged carboxylic acid, and this negatively charged carboxylic acid is a leaving group, not as good as chloride, but it's still a relatively good leaving group. هذا الحكي اللي شو اللي بيأثر على activity إنه الكومباوند is not as reactive as cisplatin, less reactive than cisplatin. So the carboplatin and oxaliplatin, the leaving groups اللي عندنا بهاي الحالة اللي هي الكاربوكسيليت. As you can see we have two carboxylates على platinum. So again the full charge لأنه two carboxylates عليهم two negative, the full charge is zero of that carboplatin oxaliplatin. So platinum oxidation state in those two compounds carboplatin and oxaliplatin is positive 2 زيهم زي cisplatin. بس الاختلاف انه الكلورايد was replaced with carboxylate which is less reactive leaving group or not as good leaving group as the chloride. And so carboplatin and oxaliplatin, they can stay in the bloodstream for longer time without being attacked by the thiols. They're less reactive, they can reach the cancer cell in larger concentration or larger quantities. About 40% of carboplatin and oxaliplatin can reach cancer cell much better than cisplatin because carboxylate is not as good leaving group. لما يوصلوا للكانسر سيل هناك راح يصير لهم نفس البروسيس الاكويشن بروسيس and then they will be the active form اللي هو diactive form of that platinum will react with the DNA and alkylate the DNA. واضح؟ So الاختلاف between carboplatin oxaliplatin and cisplatin الاختلاف الرئيسي اللي هو عندك الليفينج جروب بطلت الكلورايد صارت كاربوكسيليت in both of these two compounds. As you can see these are carboxylate attached to platinum. اوكي واضح الجميع؟ طيب هلا اذا هاد بوضح لنا انه تغيير الليفينج جروب من very good living group just to good living group or less reactive living group حسن الاكتيفيتي and let the compound stays for longer. هلا these are all FDA approved compounds وزي ما حكينا كلهم as you can see platinum 2. بينما لو بدنا نشرح عن compound جديد it's not yet FDA approved but still being studied by different companies for treatment of various cancers. You can look at the satraplatin, and satraplatin in this case the platinum oxidation state is 4. ليش 4؟ 2 negatively charged carboxylates, 2 negatively charged chlorides as you can see, and then 2 negatively charged carboxylates. So the total charge of platinum here is plus 4. Plus 4 platinum is less reactive than plus 2, which makes this compound as much more stable. In fact, this compound can be given orally to the patients, and you can give it orally to the patient. Stays very good for a long time in the GI. It does not get affected by stomach acidity or GI conditions. It can be absorbed through the GI and reach the bloodstream and reach the cancer cells. So the satraplatin is a platinum plus 4, less reactive than platinum 2, which means more stable. Can be given to the patient orally, and this is a big advancement in the organoplatinum complexes compounds. نكون خلصنا الجزء السابق اللي هو الالكيليتنج ايجنتس. حكينا عن different alkylating agents اللي هم عباره عن nitrogen mustard, nitrosurea، حكينا عن miscellaneous compounds procarbazine dicarbazine، وحكينا اخر شيء عن السيسبلاتينم organocomplexes compounds. هلا نكمل بالجروب الثاني of anti-cancer agents اللي هي عباره عن anti metabolites. وبالانتي metabolites راح نحكي عن compounds. These are compounds from their names. اسمهم anti-metabolites. شو يعني anti-metabolites? These are compounds or drugs that inhibit the use of normal metabolites that exist in the body, which is another chemical that's part of normal metabolism. يعني basically هذول compounds عندنا normal metabolites موجودين بالجسم، الجسم بيستخدمهم to build necessary structures زي DNA. And these compounds they these metabolites, or they prevent the use of those normal metabolites to build the right structure. So these compounds look like normal metabolites, but they're not, they're different. They end up being either blocking the synthesis of this essential part of the cell, which is specifically the DNA, or they inhibit the enzyme that's used to build those DNAs or nucleotides that are necessary for the building of the DNA. An antimetabolites defined or known as compounds that serve as full substrate for critical nucleotide biosynthesis enzymes. And so these compounds look like those full substrate or the substrate الموجودين بالجسم اللي الجسم بيستخدمهم عشان يصنع النيوكليوتايدز. The antimetabolites look like super attractive version of the normal substrate of these normal metabolites. So the body thinks these are normal metabolites. They're very similar in structure. They try to use them to build the DNA using those. So the result of that, either you have a DNA with the wrong structure in it, and that means a damaged DNA, or it could even bind covalently that antimetabolites to the enzyme that's used to build those nucleotides or build even those DNAs. So these are the two main ways how those compounds work, by either incorporating themselves into the DNA, destroying the DNA because they're not really a right metabolite, or they inhibit the enzyme that's responsible for the synthesis of the nucleotide or the DNA. In antimetabolites in general, they stop the de novo synthesis of the DNA by inhibiting the formation of the nucleotide that make up these life-sustaining polymers. The rate-limiting step or the rate-limiting enzyme of nucleotide biosynthesis are often the primary targets of these antimetabolites, and the multiple enzymes that can be used for the nucleotide biosynthesis. The ones that are rate-limiting, and the ones that are slowest usually, and we call those are the rate-limiting enzymes. These are the ones that are targeted by those antimetabolites. And a different type of antimetabolites, various types of antimetabolites. And these antimetabolites compound can be categorized based on the nucleotide they inhibit. They could look like purine or inhibit purine nucleotide synthesis, or they could look like pyrimidine or they inhibit the pyrimidine nucleotide synthesis. شو هم البيورين nucleotides؟ طبعا الكل بيعرف شو هم البيورين nucleotides اللي هم زي اكزامبل عليهم اللي هم الادينوسين مونوفوسفيت او الجوانيسين مونوفوسفيت. البيريميدين nucleotides, these are either cytosine, thymine or uracil. وطبعا مهم جدا تعرف انه البيورين والبيريميدين الاختلافات بينهم بالستراكشر راح نحكي عنهم من التلبت ليتر، بس بيهمني تعرف انه البيورين اللي زي الادينين والجوانين، بيريميدين زي السيتوسين، ثايمين واليوراسيل. هذا الحكي لازم الكل يعرفه. الشغله الثانيه لازم تفرق بين النيوكليوسايد والنيوكليوتايد. شو الفرق بين النيوكليوسايد والنيوكليوتايد؟ Basically, nucleoside is the sugar plus the nucleobase. This is the nucleoside. النيوكليوتايد هو sugar مع البيس مع الفوسفيت. So nucleoside is nucleotide minus phosphate. واضح؟ And the nucleotide is the nucleoside plus phosphate. هذا الحكي لازم تعرف the difference between nucleoside and nucleotide. For these antimetabolites to be active, they usually have to be in the nucleotide form, which means they have to have the sugar in addition to the nucleobase. طبعا النيوكليوبيس راح يكون هو false metabolite، مش راح يكون حقيقة النيوكليوبيس اللي يستخدم for building of DNA. So these will be the structure plus sugar plus phosphate. So they have to be in the nucleotide form. And these compounds are generally cell-specific with the activity in the S phase. So these compounds, as we said, there's two important things. They're classified either purine-like compound or pyrimidine-like compound. Purine inhibit antimetabolites. They inhibit the synthesis of the purine-based nucleotides, adenosine monophosphate, or the guanosine monophosphate biosynthesis. بينما البيريميدين antagonists, they usually inhibit the pyrimidine-based. بينما البيريميدين-based pyrimidine antagonists, they inhibit the pyrimidine-based nucleotide synthesis. زي specifically أكثر واحد أهم واحد اللي هو الديوكسيثايميدين مونوفوسفيت. واضح؟ الشيء الثاني المهم اللي حكينا عنه اللي هو administration of those purine and pyrimidine antimetabolites. They require the formation of a nucleoside, and then finally they will be converted to the nucleotide by addition of phosphate to have their antimetabolite activity. Okay. طيب خلينا ناخذ أول جروب اللي هم antimetabolites with the pyrimidine-like structure or pyrimidine-based drugs of antimetabolites. So the pyrimidine-based drug of antimetabolites, these are compounds inhibit the synthesis of pyrimidine structure. Specifically لما نحكي عن pyrimidine structures, we're talking about the cytosine as the, the thymidine as the main example, not the cytosine, the thymidine as the main example. Okay? Done. So basically, these pyrimidine-like drugs, they inhibit the synthesis of thymidine. And the way they inhibit the synthesis of thymidine is basically by blocking a specific enzyme that we call thymidylate synthase. طيب هلا كيف بنصنع احنا thymidine, if we need to know how is it biosynthesized in the cells, is basically thymidine is made from uracil, and this is the structure of thymidine and uracil. شو الاختلاف between those two compounds? The main difference between those two compounds موجودين عندنا اللي هم either you can see in the thymidine or the uracil, the main or the only difference between those two compounds is the presence of this methyl group. And that methyl group between those two compounds is the one that's necessary to make the thymidine. So the thymidine is biosynthesized from uracil. الuracil موجود عندنا بالجسم، بدنا نحوله لثايميدين. كيف بنحوله لثايميدين؟ By addition of methyl of that position, and that position is position number 5, as you can see. So on position number 5 كيف نعمل الكاونتينج؟ طبعا الكل لازم يكون عارف بنبلش من هاي nitrogen number 1 and then carbon 2 and then nitrogen هون number 3 and this carbon number 4 and then we have this carbon is number 5 and then we have 6 is this position over here. So the difference between thymidine and uracil is the presence of that methyl على carbon number 5. So to biosynthesize thymidine بالجسم نستخدم الuracil بنضيف عليه methyl على carbon number 5, and that's made with the help or the assistance of this enzyme that we call thymidylate synthase. So this thymidylate synthase takes uracil and converts it to thymidine with the help of cofactor. طبعا الانزيم had basically the main reason for the enzyme is just to reduce the energy barrier of this reaction. بينما there is a source for the additional methyl that's added to the thymidine, and that source is coming from a tetrahydrofolate species that we call 5,10-methyl tetrahydrofolate. من اسمه or methylene tetrahydrofolate. من اسمه في عندنا additional methyl على tetrahydrofolate and that methyl will be transferred from that methylene tetrahydrofolate to thymidine, to uracil to make the thymidine. So again, this to make thymidine عندنا بالجسم عندنا الثايميدين بنستخدم uracil باستخدام enzyme موجود enzyme اللي هو thymidylate synthase. It converts uracil to thymidine, and you need in addition to that a cofactor that has the methyl, this additional methyl اللي هو 5,10-methylene tetrahydrofolate. That 5,10-methylene tetrahydrofolate will provide an extra methyl for the enzyme thymidylate synthase, which adds this methyl at position number 5 on the uracil and allow the synthesis of thymidine. خلينا نطلع هلا على structure of 5-fluorouracil, which is one of the most well-known examples على drugs of pyrimidine-like drugs of antimetabolites. And that structure, as you can see, of 5-fluorouracil is very, very similar to thymidine and uracil, except at position number 5 we have this fluorine instead of hydrogen اللي موجود بالuracil or methyl اللي موجود بالthymidine. So الاختلاف between 5-fluorouracil, thymidine and uracil اللي هو basically عندنا it's a uracil structure with a fluorine at position number 5. طيب عشان نعرف كيف ال 5-fluorouracil works specifically, we have to look at the mechanism. How uracil is being converted to thymidine. How does the thymidylate synthase enzyme convert the uracil to thymidine? This is the slide that shows this specifically, the mechanism, how this happens, that you convert your uracil to thymidine. So to synthesize thymidine, we need to convert uracil to thymidine by addition of methyl. Now, first of all, for this reaction to happen, we need two things: so thymidylate synthase enzyme, and we need the cofactor, which is 5,10-methylene tetrahydrofolate. In addition to that, we need uracil to be in the nucleotide form. For any nucleobase to be able to react with enzyme and to build any structure, any reaction بالجسم, it has to be in the nucleotide form, not in the nucleoside, not in the nucleobase. It has to be in the nucleotide. So uracil has to be in the uridine monophosphate, and this is the structure of that uracil in that case. As you can see, uracil is a uridine monophosphate. A uracil structure over here, as you can see. and then we have this sugar moiety as well, in addition to that phosphate part. So this is a nucleotide form of your uracil. So for that reaction now to happen to convert it to thymidine, we need to add a methyl group, and that's usually added, as I said earlier, at the position number 5. So if you have two things, we have the 5,10 methylene tetrahydrofolate and the thymidylate synthase enzyme. The enzyme has a thiol as part of a cysteine amino acid. That thiol will do a Michael addition, a 1,4 addition. وحكينا سابقا عن Michael addition. We have in a Michael system, we have this carbonyl, and then we have this double bond attached to that carbonyl. This is a Michael system. واضح? And you can see that this position over here is the position that will be attacked by the nucleophile. There's an electron deficient position or electrophile position, and if you draw the resonance of that Michael system, you'll see why this position over here is a electron deficient. Why it's an electron deficient position. And so you can see that there is if you have a thiol, for example, this is a nucleophile, and that thiol can do this nucleophilic attack at the position with a lone pair of electrons, as you can see in this slide. So after this nucleophilic addition, now the next step, if you make a bond between the thiol over here and the carbon number 6, as you can see over here, you break this double bond, and this lone pair of electrons اللي موجودين بالرابطة على carbon number 5 راح يروحوا يعملوا attack nucleophilic attack على وين؟ على الكربون اللي موجودة بال THF. Extra carbon هاي اللي هي 5,10 methylene THF. And so when this happens, now you have a ternary complex of your enzyme covalently bound to uridine, and that uridine is monophosphate is also covalently bound to THF or methylene THF. Okay, and so you can see all those three things are now covalently bound to each other in a one ternary complex. It's important to know, راح امسح هذول الاشياء اللي كتبتهم فورا. And then so it's very important to know that for this reaction to continue now, what happens is you have a proton على carbon number 5. That proton will be abstracted by a base موجود بالenzyme, and that once you abstract this proton, now you can eject or kick out this THF. So that leaves behind this intermediate where it's basically a uridine with your enzyme and then the extra methylene that you have in your structure. By addition of hydride موجود from the THF, you will convert that methylene to methyl group, and now you have this thymidine monophosphate. So you can see that this process happened stepwise, and the thymidylate synthase عمل first attack على position number 6, followed by position number 5 on that uridine monophosphate will do a nucleophilic attack على الميثيل اللي موجودة بال THF. Now you generated a ternary complex of your enzyme, of your compound, your uridine monophosphate, and then THF. And in that case, the new methyl, the compound مرتبط على THF on the methyl that will be added to that uridine. And so the next step is that you بتشيل ال THF, leaving just the methyl, the additional methyl behind with the uridine, and that's exactly what happened over here. And then this additional methyl will be converted back, as you can see, to thymidine with the elimination of your thymidylate enzyme. واضحة الستيب هنا أو mechanism. If you have any questions, just ask me those questions. إذا ما كان في نقطة أو شيء مش واضح, and I can definitely try to explain this even more. Okay, so it's important to know هنا في كثير important step to know, or important part of that enzyme, that this راح أمسح بس هون الشغلات اللي كتبتهم quickly عشان to make it easier to see. So you can see in that specifically this hydrogen اللي موجود على position number 5 is very important. ليش very important? لأنه you need to take that hydrogen proton to be able to eliminate or remove this THF. واضح؟ If you don't have this, if this hydrogen does not exist on at this position, if we don't hydrogen at position number 5, we cannot do this step. راح يظل بالternary complex. ليش؟ لأنه you cannot take proton, so you cannot eliminate this THF from that complex to generate your thymidine with the enzyme, and then eventually eliminate the enzyme and leave the thymidine. So this is exactly why 5-fluorouracil will inhibit the thymidylase synthase enzyme irreversibly, will stay with the thymidylate enzyme. 5-fluorouracil مش موجود عنده hydrogen، موجود عنده fluorine, and fluorine cannot be abstracted زيها زي البروتون. And so it's important to know that in 5-fluorouracil, السبب إنه this compound it irreversibly inhibits the thymidylate synthase because this fluorine is not a leaving group. It's not going to be taken out as proton or removed as proton, so it will stay there. So if we do the same mechanism as previously we did earlier, this compound ال 5-fluorouracil first of all عشان يتفاعل مع الانزيم لازم يكون بالنيوكليوتايد فورم. احنا حتى لما نعطيه 5-fluorouracil still we need to add الجسم راح يضيف عليه sugar, so it's a prodrug that you need to add sugar to it as phosphate to generate the deoxy or the 5-fluorodeoxyuridine monophosphate, which is the false substrate, the active form. So 5-fluorouracil is a prodrug. It needs to be converted to the nucleotide form by addition of sugar and phosphate to be able to react with the enzyme. واضح؟ طيب هلا أهم نقطة تعرفها عندنا هون عن 5-fluorouracil اللي هو this fluorine is not like proton earlier, but cannot be taken out. It will be stuck in the ternary complex step. شو راح يصير لو اطلعنا نفس الميكانيزم that we did earlier? Cysteine of the thiol of the cysteine on the thymidylase synthase will attack this carbon number 6, followed by a nucleophilic attack of carbon number 5 على الميثيلين اللي موجودة على THF. شو اللي راح يصير عندنا؟ راح يصير عندنا ternary mixture ternary complex اللي حكينا عنه سابقا اللي هو هذا التيرنري كومبلكس. شو فيه التيرنري كومبلكس؟ موجود فيه THF ميثيلين THF رابط على شو؟ رابط على 5-fluorouracil nucleotide، كمان رابط عليهم اللي هو الانزيم through the thiol of that cysteine. So this is a ternary complex. هلا next step شو كان المفروض يصير أو شو اللي المفروض يحصل؟ إنه basically there is a base will take that proton اللي موجود على carbon number 5. بس عندنا ما عندنا بروتون، احنا عندنا فلورين. الفلورين is not going to be taken، مش زي البروتون ما تقدر تاخذها وتطلعها من structure. So that ternary complex will be stuck at this stage, which means you inhibited the thymidylate synthase irreversibly لأنك كونت covalent bond مع 5-fluorouracil, so you deactivated that enzyme irreversibly, and now you prevent the synthesis of thymidine. متى بنتخلص مثلا من 5-fluorouracil effect؟ لما كل الانزيمز هذول الجسم يتخلص منهم، يعمل انزيم جديده بالجسم، ساعتها ممكن نتخلص من الافكت of 5-fluorouracil. واضحه؟ So the main thing that you should know is the 5-fluorine is stable to elimination in that ternary complex, and the terminal product results involving the enzyme, cofactor, and substrate are all covalently bound in a ternary complex that's not going to be broken. Stuck at this stage, it will stop at this stage، راح يكون موقف على الستيج وراح نعمل irreversible inhibition for that thymidylate synthesis. اوكي ان شاء الله يكون كل شيء واضح عندكم هلا. ان شاء الله يكون كل شيء واضح بالميكانيزم اللي حكيته. If you have any questions، اذا عندك اي استفسارات على الموضوع اسالني بجاوبك، بس يعني يكون عن طريق e-learning or other ways if you want. And that should be it for this lecture. إن شاء الله يكون كل شيء واضح عندكم ويعطيكم العافية.